Hello, welcome to 4.3, Angle Bisectors. Okay, so our first definition for this lesson is adjacent angles. Basically, adjacent angles are two angles that share a ray. Okay, so the official is that they're two coplanar angles that have a common side and a common vertex, but no common interior points. So they're side-by-side angles and they share a side. Here's an example of adjacent angles. So you would see BAD is adjacent to DAC. Okay, they are both interiors are shared together by BAC. You see that big angle BAC combines both of those smaller angles together. Okay, BAC and DAC are not adjacent angles. So look carefully at the lettering. This is BAC. Okay, it cannot be adjacent to anything that's already included in itself. Okay, so if I look at DAC, it obviously is not adjacent. It's interior to BAC. Okay, so I hope that makes sense. It's really important that you pay attention to the labeling. And this is not adjacent because it does not share a vertex. Okay, angle CDE is its own separate identity from BAC. Okay, your first postulate for this section is the angle addition postulate. We're going to be using this a lot when we start writing proofs, so it's important that you understand that. This is a little bit like betweenness, but not quite. Okay, we use betweenness a lot in proof writing as well, but if K lies in the interior of angle MNP, then the measure of angle MNP equals the measure of angle MNK plus the measure of angle KNP. Now, of course, we need a picture to go along with this, or it's just a bunch of letters, right? Okay, so we want to find the measure of XYZ. Okay, this is the larger angle. If the measure of XYT equals 25 and the measure of TYZ equals 15, the angle addition postulate says that I can add the two smaller angles together because they are adjacent angles. So if I go ahead and do substitution, put in the measurements of 25 and 15, I will know what the measure of the large angle is. Okay, this example is also on page 130 in your text. Okay, so let's look at another example. This one we have to do a little bit of algebra because we already have the large angle that is ABC. Yeah, I wasn't sure if I was saying that the right order at first. ABC is the right angle, okay? Together with DBA and CBD, we add those two together to get that, but we need to find what the little angle is. So if 90 equals 70 plus the measure of DBC, what is DBC? Well, hopefully we remember our algebra skills, which means we would subtract 70 from both sides, and then we would get that that angle is 20 degrees. So here I have the large angle I need to find. I have the two smaller. They're both adjacent. So hopefully you can add those two together for yourself. The answer is 50, in case you're not sure. Okay, so let's do one more example here. Actually, I think I have two more for you, but I want you to practice this one. I want you to hit pause, see if you can do this by yourself, and then come back and check your answer. Okay, so I was given the large angle and I was given one of the smaller. So I had to do some subtraction with my algebra to find the measure of QRV. Same with this one. I want you to practice this one by yourself. Here's the picture that I drew. The pictures are really important, okay? The interior and the exterior, that's going to make all the difference on whether or not that you get these problems correct or not is your drawing. Okay, the drawing makes or breaks you. So, if I have angle ARQ, and I have angle ARV, I'm going to add those together, and I'll find QRV. Okay, we've talked about a segment bisector and how that is the midpoint of a segment. Now we have an angle bisector, okay, and we're going to create a ray that is in the interior of the angle and forms two congruent adjacent angles. And then a perpendicular line are lines that intersect to form two right angles. Okay, so the symbol for perpendicular is kind of an upside down T. It actually is a perpendicular line. The reason why we're going to be talking more about these two things later when we go to do constructions of them, and then also we can use the angle addition postulates. If we have two adjacent congruent angles and we add them together, that means that that angle is half of the big angle, and same with perpendicular. If I have a straight angle, then half of the straight angle is 90. So things that we would maybe already understand, we have to be able to explain now. Okay, so for your WSQ summary, this may seem unrelated to this lesson, but trust me, it is. If you look at page 131 in your textbook, there's a picture of Thomas Jefferson's home in Monticello near Charlottesville, Virginia. Unfortunately, when we went to Washington, D.C. last year, and we didn't get to visit. So I just want to point out that this is a marvelous piece of architecture, just like the Biltmore and the, what was the other, gosh, I'm blanking here, the Dome on the Rock. We've talked about those two. So we're going to talk about architecture a couple more times in this chapter. But anyway, I want you to find the answers to these three questions. Which coin is Thomas Jefferson's home at Monticello displayed on? And 2, is the back of the house the same as the front according to the floor plan on page 131? And number 3, using the walls, that should be plural, okay, the walls on that diagram, what kind of polygon is the house? So in other words, how many sides does that house have? Not polyhedron. I don't want to know about its 3D shape. I just want to know about its 2D shape. Okay? And I'll see you in class.